So here we are with our ReGenX generator operating on no load. Our input current to our prime mover is 1.49 amps and our speed is 3,502 RPM, and we're on no load, so I'm going to put it on load right now. I'll be putting it into regenerative braking mode with the conventional coil that's in this prototype. So now we are on load. We are generating 0.89 amps through our purely resistive load. Our speed has dropped to 3,482 RPM, and our current to our prime mover has increased to 1.62 amps. And we can see the load current sine wave on the oscilloscope. And now I'm going to put the regenerative acceleration coil on, and we'll be able to see the load current will increase, the speed will increase, and the current to the prime mover will decrease. So now we are in regenerative acceleration mode. Our speed has increased to 3,505 RPM. Our input current to our prime mover has dropped to 1.48 amps. Our output current across our load has increased to 0.92 amps. And we can now see the delayed load current sine wave in blue, the delayed ReGenX coil's load current in blue on the sine wave on the oscilloscope. So I will put it back into basically conventional generator mode, regenerative braking mode, so you can get a sense of the difference again. So now in conventional regenerative braking mode, our speed has decreased, and we can see the conventional load current sine wave on the oscilloscope. And I'll put it into regenerative acceleration mode again. So the more current that we take from our conventional coil, the more system deceleration we will incur, and the more current we take from our regenerative acceleration coil, the more acceleration we will incur, and the less input current and input power is required to be supplied to the prime mover. Put it into conventional mode once again. And I'll put it into idle once again. So we can see that as far as our prime mover is concerned, if this is regenerative braking mode, you can see that our regenerative acceleration performance from the prime mover's point of view, is better when we are in regenerative acceleration mode, meaning the input power required to be supplied to the prime mover is less when we are recharging the EV's batteries than when we are in no load, not in regenerative braking mode or not in regenerative acceleration mode. So as far as the prime mover's load is concerned, it's easier to run the motor and requires less power in regenerative acceleration mode than it does in idle mode.